Okay, this is conceptuality15a video. I'm going to just again a little bit of review. Now, we have the tetrastar here, right? This is the connection, the interpenetration of two tetrahedrons forming the octahedron in the middle. And then, of course, that manifests the cubic structure just by connecting the points of the star, right? I hope you can see that by now. It's really so simple. Well, it is after you think about it for years. But anyway, here's the two tetrahedrons, right? Here's the black one and the red one interpenetrated. That should be pretty obvious. Now, we know that we have the octahedron in the middle, right? And here is that octahedron, okay? Now, we've talked about the implosion. Now, when we this with the tetrahedron on the face is the octet star. All you have to do is put them on each face, all 8 faces, and you have the octet star. Okay, now what we're going to do is implode this tetrastar, or this tetrahedron, into the octahedron, okay? Now, we do that on each face. Everywhere there's a tetrahedron, we implode it. Then we come up with this configuration here. Can you see that? Well, it's just difficult to see. But if you built these models, they're really easy to build, and you would see. But here's the tetrahedron from the back face is the center of it here. The center of the opposite face here. The center coming from the opposite face here of the tetrahedrons that have been imploded. They go all the way to the opposite face of the octahedron. Then we have built automatically inside this rational structure. You don't realize how rational it is until you study it a little bit. But it creates a cube that has the points of the cube, the corners of the cube, exactly in the center of each octahedron face, okay? Like this. This I call the big cube. That's automatically, first thing you see, it's the thing that happens, okay? And it goes down like this, and there's the cube. Okay, now there's another cube that's formed inside, in the very center of that square, which is, I guess this model is the best one to use to see that. It's not going to be that easy, but at least it's, this is the octahedron, okay? This is the cube I just showed you in the other model. And then way inside here, let's see, way inside, right here, there, right here, is another little octahedron that forms inside a tetrastar that's formed here with the second internal cube that forms. So there's 2 concentric cubes going inward, and inside the small one is our original octahedron that we always explain through this model here, okay? Now that there's an octahedron right in here. Now, the interesting thing about this is that we think that we're in this original construction, we're taking what we would just assume to be a 1-frequency octahedron. We haven't defined it to be anything else. We're imploding it, making these connections, and we find that the internal octahedron that should be 1 frequency, just like this one, right? If we make that one, if we assume that one to be 1 frequency, then this dimension here, the frequency of the whole octahedron becomes 5. You just sort of have to accept the word on that, but it's it's mathematically absolutely provable that when this is a frequency 5, you implode it, you get a frequency 1 octahedron in the middle. Okay, and that's just the way it is. Okay, now when you change this frequency to 15, a really interesting thing happens. Okay, that these dimensions, we know that this dimension is the tetrastar, the tetrahedron imploded, right? Or is this vector right here going across, and at 15 frequency, this becomes a exact ratio of 6. This becomes 6 frequency, and the rest of it, the other side of it, is 9. So that it's really that, and then the whole thing, all the rationality unlocks once you see that then this frequency becomes 15, because 6 and 9 is 15. Actually, we interpret this from knowing this frequency. We just assume this frequency to be 15, and then when you do all the mathematics, all the geometries, just with Pythagorean theorem, you would determine that this is 9 and this is 6. And then everything else that I have explained in the writing becomes completely rational. So I think that's about as much as it can be absorbed in this one video. Okay, it's totally amazing. Now, if you think about this, that there's cubes here, and I will show you, but probably better in another video. This cube, in this case, it occupies 1/3 of the diameter, or of the diagonal across here. And that small cube that's inside will occupy 1/5. In other words, there's going to be 2 cubic arrays in here, one with three frequencies across, which would make the whole domain of the whole cube that is indicated by the outer octet points. This cube would be 27 cubes, and the smaller ones, there would be 125 in this big cube. It's so beautiful. It's all rational and even. I guess that's it.